Today's video is going to be about comparing two different objectives. The first one is our base case objective, which is maximising the net present value. The second one is when we maximise the reserve cash flow. So people can think that if you have a greater reserve, then you'll end up with more money for the shareholders. So we're going to be using COMET ONE to compare these two cases and see why that's not always the case. So we're going to be using the Antarctica mine, the 10 sequence Antarctica mine. Make sure you select that one. And then because we're comparing these two cases of different objectives, let's go down and select the maximum reserve cash flow. So when we maximize the reserve cash flow, what we're actually doing is in each period, we're seeing if by changing the cutoff grade a little bit, you can add a little bit more reserve that makes you another dollar. You'd expect then that we wouldn't go right down to the very lowest grade material, but we'll stop at the point where the economics mean that you don't actually make any more money for the extra ore that you're processing and mining. So that's what we've got here. You can see that this has already gone away and calculated the difference between these two objectives. You can have a look at the input parameters at your leisure. So the first result that we can see is this table of key numbers. So the most important number is the net present value. So you can see the base case with the maximum net present value has an NPV of $7.7 billion. And when we maximize the reserve cash flow, we actually lose some value. We only have $6.1 billion. So we've lost about 21% of that. Interestingly, our reserve has increased. So we've gone from 16.7 years up to 25.2 years. So quite a significant increase in life. And you can see the amount of ore has increased. So you'd expect that if you have more reserve, more material that's being processed, then you'll have a greater amount of ore and you'll have a greater life, and your life will finish earlier. But why is it that our net present value has actually gone down when we've increased the amount of ore that's making money? The next pie chart shows you just how much money we've lost from a discounted value point of view, from a net present value point of view, which is our best proxy for shareholder value. So you can see it's quite a significant amount. In this case, it's 21%. Now, every case will have a different percentage. You can't just say that it's going to be 21% for every project. But it does give you an idea of just how significant this is. And it's worth considering if you were using an objective of increasing your reserves, it would be worth considering whether maximising the net present value would give you a significant boost to your value of the project. So let's come down and have a look at the mining schedule. So the top chart is for the base case, maximising NPV, and the second chart is for the maximum reserve cash flow. So what you can see here for a start is that the mining schedule is a lot shorter for the base case. So we've extended, this is where we have the extra mine life over here. And so we have a lot of material being mined later in the period and less material mined earlier in the period. So we mine the same amount of total rock, we just push it back. And the way that we've pushed it back is actually by lowering our cutoff grade. So you can see our cutoff grades here are quite a bit lower than the ones above. Both of these charts have been scaled identically, so the axes are all on the same scale, so it's quite easy just to compare the two schedules. So when we drop our cutoff grade, we have less waste. So you can see here the waste that we mine is much less, and that's how we create the extra ore. We actually turn material that used to be sent to the waste dump up here by dropping the cutoff grade. All that material is now sent to the processing plant. So why is it that this didn't actually make us more money? So let's have a look at the next two charts. This shows us the revenue, costs and profit of the two different cases. So again, you see the maximum reserve cash flow has a much longer life and materials coming into the mine life right up until this 2045 instead of finishing up here at 2036. So quite 8.5 years of extra life. Now, what you can also see is that the revenue is fairly consistent with this project, with this second plan. So $1.3, $1.4 billion of revenue each year, whereas this other one, we're actually seeing some peaks of around $1.8, $1.9 billion. And although we drop down sometimes to 1.5, we're on average much higher revenues in the early periods. Eventually we get down to the 1.4 type billion dollars a year revenues. Likewise, if you look at the costs, they're fairly consistent down here. They're not that different here either, because a lot of the costs are related to processing. And so we have a little bit higher costs here, like $780 million a year in these first years, 715 down here, so a little bit higher up here. But one of the really big areas that are different is that we have the discounted value of the profit plotted here. And you can see in the early years, we're looking at $800 million a year going to the project value. Whereas down here, we're looking at like $500 million a year. So quite a significantly lower amount of material value being produced by the project. But not only that, it's being produced in the early years. Even though we have good cash flows going out right throughout the mine life, the last years of the mine life contribute a very small amount to the total net present value of the project. Let's look at some of the numbers behind these charts now. If we look at the summary statistics, you can see that the base case cash flows are actually quite a bit lower than the maximum reserve cash flows. So we generate a lot more money in terms of cash flow, but the problem is the discounted cash flow is much lower. So more value, but produced over a longer time. So this reserve cash flow didn't take into account the time value of money. It just looked at the value in the current period and just said, look, can I make another dollar with this extra piece of rock and at this cut-off grade? And if you can, it included it. So we have a very large reserve. You can see our ore mass is quite a lot higher, our metals are higher, and our revenues and total revenues are higher. But the discounting is the part that really suffers on this objective of maximising the reserve cash flow. You can see here that multiple objectives don't always align, that each objective results in a different schedule, and the different schedule produces a different value, different decisions, different life, different reserves. This means that you can't just use any objective. You need to go for the objective that's going to give you the most value back for your shareholders. And the best metric we have of this is the net present value. Feel free to leave some feedback and comments below, and go make the most of the resources that we steward.